regression. You have learned statistical tools, hypothesis test, ANOVA, chi-square test. Uh, then we have got ANOVA, chi-square test, and binary logistic regression. I already told, and you have also learned a lot of probability concepts. So that is also part of data science, by the way. Plus, of course, Python, which is very, very important if you want to become a data scientist. So let me quickly tell you, what do you mean by artificial intelligence? Artificial intelligence. So intelligence is the computational part of the ability to achieve goals in the world. So what is intelligence? If you have a goal, you are in a current state, you have to achieve a goal. Then usually using intelligence, using logic, using some you say tactics, you can achieve the goal. The ability to do that is intelligence. Now, what is artificial intelligence? If I tell machine to do the same thing, then that is artificial intelligence. So it is making machines do what the human beings can do. Yeah, especially the computational part. Now, the goal of AI is to create agent, artificial agent, who can take inputs from the environment, process that input, process that information, and based on certain logic, based on certain algorithms, based on certain conditional statements. In a way, I'm trying to not use too many jargons here. So you will, the agent will act on the environment. Think about yourself, like, as a human being today, what you do, you perceive the environment through your eyes, nose, ears, that is sensors, right? We all have sensors. So we perceive the environment. And after perceiving the environment, after taking the inputs from the environment, we process that information with the help of all the logic, which we have learned over the period of so many years, and also the knowledge. We have got a database of experience and knowledge which we have learned in our schools and college and from the environment. And we process that input with the help of all the learnings, and we act on the environment through effectors. Effectors means our hands, legs, tongue, facial expressions, etc. So what if I make an agent who can also perform all those activities? That's the goal of our AI, artificial intelligence. So you can prepare, you can make a simple reflex agent, who can sense the environment, and based on some condition action rules, who can take an action. And it's a simple reflex agent. Or you can also have a utility-based agent, where I give assign some task to that agent to increase the utility points. Okay, to increase the utility points. So what is utility points? To take a very simple example, let us think that you would like to, in school, if you remember in school, how did we learn? Our goal was to increase the scores, the marks which the teacher used to give. That was our utility points. So higher the marks, we were happier, and we were trying to achieve more and more percentage in our examination. So that was our utility points in a way. So whatever made us achieve more points or more scores, we would tend to do that activity. Usually, most of the students used to do sometimes people don't care, that's a different thing. But usually you will, you will try to achieve maximum scores. So similarly, I also create a utility-based agent whose goal is to increase those utility points. They could be anything. Another example, like in a football match, you want to score as many goals as possible. That is your utility point. Or today, in today's world, let's take our example. For us, the utility points is, can you guess what is the utility point for all of us? Why do we work? all our efforts are aligned towards that, increasing that utility point. So can you so can you Rishabh, can you accept being the panelist, please? If Rishabh, if you are there, you'll have to accept to become a panelist. Okay, both. He has actually logged in from two, right? So he has logged in from two systems, right? Yeah. Okay, great. So as I was telling that a utility-based agent is someone who tries to increase the utility points. So I was asking you a question. What are your utility points today, nowadays? Can you make a guess? Uh, yeah, money. Yes, money. So you would like to maximize the money. So money are your utility points. So similarly here, I'm trying to create a utility-based agent who will try to increase the utility points. Some examples we'll give in a short while. It all started long time ago. I'll not go into the details today. Let's learn about more focused. Let's have a more focused approach today of ChatGPT. But yeah, one thing I would like to tell you: see, a machine is artificially intelligent or not is determined by a Turing test. So, what is Turing test? So we have a AI agent and a human being. So this is a human being. He is a human, and this is the machine. Yeah. So A is machine, B is human being. And then C is also a human. Now, C doesn't know in which room you have a machine and which room you have got a person. Now he interacts, Mr. C interacts with both machine and human being. And if he is not able to differentiate between the two, if he is not able to find out who is the machine and who is the human being, then in that case, you know, we say that that machine is uh, can be designated as an artificial intelligent machine. So that is the basic definition of any machine or any agent uh, to get qualified as an AI application. And yeah, so John McCarthy is the father of AI. 1956, he coined the term called artificial intelligence. And yeah, so today, as we are, because of the computing power of multiple systems which are at our disposal today, we are progressing really fast. Although the concepts, the algorithms, and the statistics, and in fact, I remember even in 1989 or 1990, we had some of the subjects which talked about neural networks. Yeah. In statistics also, I had learned about neural networks, but that was pure mathematics and pure formulae, which we did not find too much interesting. And we never thought that, after 30 years, I'm talking about 1990, that after 30, 35 years, things will be so different today. And how the world changes in just 20 years, 30 years, actually, we, the old people like me, are really a witness to that. So some of the main branches of AI are, of course, we'll not be discussing all of them. So some of them are discussed here. NLP, robotics, vision systems, neural networks, learning system, expert systems. Expert systems are those systems where I download information from a human who could be an engineer, physician, etc., using a knowledge engineer. He downloads all the information, creates a knowledge base. So this knowledge base is created, and using an inference engine based on some logic uh, as given by the human experts, you create an user interface, and any user who may not be an expert can interact with this expert system and get his answers. And these answers are sometimes better than an individual expert. Yeah. So the expert system, if you're using as a uh, see, in fact, one of the very famous examples of expert system is IBM Watson supercomputer. It means I'm talking about early examples. Of course, now we have got ChatGPT as well. It's a mix of lots of AI applications. So you will make a guess after a while, or I'll ask you that question after a while. But yeah, expert system is about uh, developing a system which acts like an expert. So if you ask a question that someone has a headache, body ache, nausea, so what's wrong with that person? AI has the answer. And then we have got actually it's a lot of videos, but I'll not show you a lot of videos today. I'll just quickly finish off the different areas or branches of AI, and then we'll quickly jump to the chat GPT part. NLP, natural language processing. All of us have heard of this. Natural language processing is about like creating a natural language or understanding the natural language. So NLG, NLU, depending on what you are trying to achieve. So you have got, like the way we learn English or any language. We used to learn, there used to be noun phrase, verb phrase in every sentence, and every verb phrase has got a verb phrase and a noun phrase. So in any sentence, I will always get one noun phrase and a verb phrase, and the verb phrase itself consists of a verb and a noun phrase. And a noun phrase in turn comprises of article and a noun. Yeah. And this is generic rule, right? So what if I teach this to the machine as well? And machine can also behave as if it is understanding the language. It will create sentences or it will understand what is written. Okay, so okay, let me maybe I'll show you. See, a lot of research in legal or healthcare industries, it's very difficult for a human being to read so much of work, research papers, or the journals which are available. Like I'm a chemical engineer originally, 1990 I graduated. Now, there's not possible for me to learn all the chemical engineering books or knowledge. Yeah. Or right now I'm, as most of you know, for the last 25 years, I've been into Lean and Six Sigma training, consulting, quality process improvement, and statistical process improvement, etc. as QC. But it's very difficult for me to learn about all the tools and techniques. Or as a data scientist, like last 4 or 5 years, I've been very much interested in this field. It's very difficult for me to learn everything. But I can develop my machine which can read very fast, understand the sentiment and emotion of what is written. It can give me the summary of what is written. So without spending too much effort, work or effort, I can still accomplish my job. So NLP is one of the ways to do that. Robots can act on the environment. Yeah. So the most of the AI applications are actually the combinations. They use NLP, robots, computer vision, neural ANN, artificial neural network, etc. So they use multiple research areas of AI, and we can develop a lot of AI applications. So nowadays you have got
robotic surgery involves using this instrument, the Da Vinci robot, which is a four-armed robot which allows a surgeon to manipulate tissue inside the body through small incisions. The instruments that you see here, these robotic instruments, are actually placed through the body through a trocar. These trocars are basically a portal between the outside and the inside of the body. These instruments have more precision and more dexterity than standard surgical instruments. This is the Da Vinci scope, and during surgery, a camera is mounted on the scope and provides a high-definition view with very intense light. This view gives me a three-dimensional vision inside the body, which allows me to see things better with more clarity than I can see with my own eyes. The robot has many advantages for surgery, and what this allows me to do is surgery with less trauma to the tissues, which means better healing for my patients.
So after some time, people will prefer to go with the robot rather than a human doctor. That day is not far away. Okay, many of you have heard of neural networks, right? So neural networks actually simulate a brain, whatever a brain does. So in brain, neurons are connected to other thousand cells by axons and stimuli accepted by dendrites. So in the geography, so not sorry, biology lessons in your school, you would have learned, we receive the inputs like from the environment, from the dendrites, right? Dendrites receive the input and pass on to another neuron through axons, and information transfer happens at synapses. And as the memory, like, whenever we learn something new, there's a myelin sheath, thickness of on these axons, it increases, the myelin sheath thickness increases, and that's how we create memories. And like, what if someone tells you that this is a pen, in our school our teacher told us this is a pen, so we created a memory, using some like neurons present in our brain, and it was reinforced, on a regular basis, that this is a pen, this is a pen. And if I gave the right answer, if someone asked me what is this, and I would say it's a pen, people will say, give me thumbs up, or my teacher would give me scores, which actually were the utility point for me. And if I gave a wrong answer, then of course my teacher would deduct some marks. This is an example of reinforcement learning. So this is how we create our memory. Now, what if I do the same thing artificially? So here the silicons and wires, they act as living neuron and dendrites, and nodes imitate neuron, and each node takes input, processes data, and passes on to the other node. And the links carry the weight. So, everything is represented by a function. So it can try out different functions, and whichever function is giving me the best result, that actually that would be my learning, and that will be reinforced in a way. So this is how, I'm just very high level giving an overview how a neural network operates. In general, some of the best applications of, or well-known applications of neural networks is teaching the machine to identify the images. So you have got different images, okay, and based on certain features, using artificial neural networks, and we can choose our number of layers. Now, optimal layer we will choose, and based on the whichever number of layers is optimal, means is giving me the best result, I will choose that. And once I see the machine is learning and is able to identify an unlabeled photo, I would say that my machine has got trained. So there are different types of machine learnings: supervised learning, unsupervised learning, reinforcement learning. Supervised learning uses algorithms like regression, multiple regression, logistic regression, and many of you have already learned that. But even if you have not learned, don't worry. In our AI and data science programs, we teach you. We assume that you don't know anything about AI and data science. We always start from ground zero. Okay, so this is how we conduct our training programs. So we have got, if I just want to, actually, let me use some of the notes, my previous notes from our previous data science lessons. So it will save our time, right? So typically you can, I can say that, data science is nothing but, actually, what is AI? If I just ask you what is AI? AI is nothing but an application which is useful to a human being. AI application is something like, self-driving car. That is an AI application. Yeah. Now, self-driving car is an AI application. So AI application, to make an AI application, you have to have engineers, you have to have mechanical engineers, to say automobile engineers, etc. Plus, you have to have electrical engineers as well, and also you have to have data scientists, and you have to have team of lot of professionals. So we are dealing with the data science part of the whole process of developing an AI. Okay. Within AI, we have got machine learning, and machine learning is statistical tools. It gives you statistical tools to explore the data. Okay. And machine learning has got deep learning as well. It means teaching the machine how to learn. Okay. So machine learning has got deep learning. And so in machine learning, we can have supervised learning, unsupervised learning, or a reinforcement learning. Supervised learning means I have got the labeled data with me. When I have got a labeled data, then I can train my machine using the labeled data. And unsupervised learning, we don't have any labeled data as such. Like classification problems, usually come under this category. And reinforcement learning is something which I will just show you. Let me show you an example of reinforcement learning. The best way is to show the example. It is like that utility point I was talking about. I'll give example of ANN also in a short while. So reinforcement learning is something like this. Like I have a robot now. I would like it to train. So I'll create some algorithm where I would say that we need to increase the scores as much as possible. Increase the score. If the robot is able to walk, it will get +1. If it is not able to walk or falls down, -2. If it falls down very badly, it is -5. Now, robot will try to optimize. Robot will try to increase the scores as much as possible. So starts committing mistakes, and once it tries it out, wherever it is able to walk, it gets additional points, and it knows what needs to be done and what needs to be avoided. And after some time, it will start walking, and then after some time, it will start running. And this is just a matter of few hours, and this will be achieved very easily. Now, all these things are very much possible, using data science. And that's what we train you. Okay. So the topics we cover in data science, I'll tell you some of the algorithms. So if you have little time, I think we still have time. So 10-15 minutes, I'll try to tell you about some algorithms. What do you mean by algorithms? How do we develop the model? What do you mean by supervised learning, etc. I'll rather not talk too much about unsupervised learning today, but if you want to know, we have got our videos in the last training. I think last one of the training, I had talked about unsupervised learning, and one of the trainings I had focused on neural networks. Most of the time, application parts. Yeah, so you can always have a look at them. You can also join our channel, Anexas channel, the YouTube channel. I strongly recommend. Please join Anexas YouTube channel, and you will get a lot of information. We conduct a lot of workshops, trainings on project management, statistical parts, statistical aspects, Lean, Six Sigma, the CPHQ, Certified Professional Healthcare Quality. Most welcome. You can also connect with me on LinkedIn, or you can follow me on LinkedIn. And I keep putting a lot of information almost every day. So you will be always knowing about the latest trends in the industry. So the data, the topics which we cover in our data science courses, Python, NumPy, Pandas. So these are all the topics which we cover. And we have got some ML algorithms which are also covered. And we have got in the intermediate, so we have got 3 levels: basic, intermediate. So these are the topics in the basic AI data science course. So basic data science course, these are the topics covered. And Intermediate, we cover classification, feature engineering, ensembles, method, etc. And NLP and NLU, that also is covered in the intermediate. Then advanced course, we kind of cover all these topics, especially the deep learning part, neural network part, which comes under the advanced topics. So we also help you if you join our courses. So of course now we'll show you some applications, but just to tell you that we have 100% placement from the past 5 batches, and we also conduct grooming sessions. We'll prepare you for the interview and job profile readiness for the job seekers. That also is provided. Yeah, so generally we conduct trainings on weekdays. Friday batch is starting May 5. Well, that was a little bit of idea, but now let us go back to learning parts. Yeah. So let me show you some examples of algorithms. A very simple algorithm, I am sure many of you might be knowing, and I'll take that example, the simple example, so that you can easily connect to whatever you have learned. Yeah, suppose I give you some data. Okay, I give you some data, which is like experience of maybe one organization which has like 10,000 employees. Okay, and I collect the data on experience and the age of the employees. I find that a person who's got 0 experience, means fresh college graduate, his age is 22. A 10 years experienced person, his age is 32. And 20 years experienced person, his age is 42. And 30 years experienced person, the age is 52. So I can make a guess if I plot this. Age on the y-axis and the experience on the x-axis. It will form almost a straight line. And deliberately, I've chosen some simple data so that I can drive home a point. So here, if I ask you, if a person's experience is 5 years, what would be his age? Can you tell me what would be his age? If a person is having experience of 5 years, what would be the age? Can you please tell me? Yeah, 27. So Nada, you're right. Amal, you are also right. Yeah. So whenever we are dealing with this type of data, which are expressed in numbers, or we also call it continuous data. Whenever we are dealing with such data, I can always fit this into a regression model. Now, this is known as algorithm. Algorithm means y is equal to a plus bx. Okay. This is the algorithm. And using the data, the existing data, and those who are a little bit aware of what is a regression equation, straight line equation, they might know what is the value of A. Value of A is at the point where we also call it as y-intercept, right? At the point where x is equal to 0. So when x is equal to 0, here we call it, this is the x and this is the y. When x is equal to 0, what is the value of y? 22. So I can create an equation. Age is equal to 22 plus, what is y 22? Because when x is equal to 0, y is y is 22. So there's 22. And 1 unit of increase in x, 1 unit of 1 year of experience increase in experience increases age by how much? It increases age by 1 year, right? So 1 and 1. So incremental value, like 1 unit of increase in X increases Y by how many units? It is 1. So the coefficient B is that same increment. So 1 here, it's 1 because 1 year experience increases the age by 1 year. So it is 1. So 1 time experience. So we'll never write 1 there, although you can write it. So 1 time experience. But this becomes my model. So we call this as algorithm. Okay. And this is the model. And what we did was here, actually, I have got the labeled data. Why this is known as labeled data? Because I have got features. These features like age is dependent on experience. So if I know the experience, I can determine the age. And I can also add on some more features. So it may happen, I encounter a person who's 10 years experience and I expected him to be 32 and he says, no, I'm 37. So I ask him what happened and he says, I had taken a break. Okay. If you've taken a break, so I'll have to include one more feature here, and that is the break. So here there was no break, but here the break was there. So I further can enhance my equation and include the break as well. Yeah. So I can keep on increasing the number of features or factors here and keep on strengthening my equation. So as long as it makes sense. So there are some ways of, we learn in regression when we are learning residuals, we try to minimize the residuals. And we also see which model is really fitting well. You can try out many algorithms. There are a lot of algorithms available. Another one is binary logistic regression, where let me use here. Okay. A customer is going to buy or not buy a certain item. So let's say the price and the decision to buy. So price is 0, person buys. Price is $1, person buys. Price is $2, person buys. Price is $3, person buys. $4, some people buy and some people even don't buy at $4. I've got. So see, when I'm giving this is a very simple example I'm giving. When I'm collecting the data will be like 0, 0, 0, and the decision, some people still don't buy and 0. So basically you're collecting the data, something similar to what I'm showing. So people are buying, not buying, buying, not buying. So 4 and 5, usually some of the people are buying and some of the people are not buying. But after 7, actually, we say that no one buys. No one buys. Okay. So if I represent this on a chart, buying is 1 and not buying is represented as 0. So as I increase my price, 1, 2, 3, 4, 5, 6, 7, 8, I'm being a little fast. I hope you are able to cope up. Are you understanding? Are you with me? Are you with me? Just let me know. Should I slow down or you're fine? Because actually now I would like Rishabh to talk more about the ChatGPT part. So I'm actually waiting for that. In fact, I'm myself, waiting to listen to him. So Mohammed is telling I'm with you. Okay, fine. So still you are with me. That's great. So we are saying yes and no. So here what's happening? Person is 0, people are buying. 3, 4 people are buying. 5, some people are buying, some people are not buying. And after 6 and 7, the decision is clear. So if I ask you one question, what is the probability of person buying an item? Price is 1. So you will say probability of buying that item is almost 100%. That is 1. What is the probability if the price of the pen is 10? What is the probability of buying that item? Well, you will say it's almost 0. Now, what is the probability of buying that item if the price is 6? So can you make a guess? What is the probability of a person buying an item when the price is 6? You might say, how much it is? I'll give you 3 options, 0, 0.5 or 1. What is the probability? If the price is 6, what is the probability? Out of 10 people, how many will buy, how many will not buy? Can you make a guess? Sorry. Yes, 0.5. Yes, you're right, 0.5. So out of 10 people, 5 will buy, 5 will not buy, right? So this S curve is actually binary logistic regression curve. So what I have to do is I have to just retrain you to identify the type of problem and type of algorithm which will be applicable to a particular problem. And that is what is needed. The rest of the work is done by Python. So Python is very easy. Today, if you want, maybe I can request Rishabh to show how to, what is Python. It's very, very easy. Or I have got certain videos also of our last training. If you want, I can play that just to tell you. How many of you are aware or have seen Python working? Okay, not many of you, it appears. So we'll show you that as well. Heard about it, not used, but very easy. It's very easy. You can download it right away. You can download it right away. Okay, so first, I showed you some 2 very basic examples, but in real life, examples would be something like this. I want to develop a model to predict whether the person has diabetes or not. Yeah, not. So if it is yes, it is 1, outcome is 1. If it is no, so this is yes, no, yes, no. So depending on these features, these are the features. Person with the skin sickness at 35, insulin 0, BMI of this, what age at 50, what is the probability he has diabetes, right? So this is the data which we have collected. I have got a lot of data. We have just shown here 4 or 5 columns, or sorry, 5 rows, but in reality, we can have thousands of rows of data. And I divide the data into 3 parts, 60% for training. In fact, see, before I create a model, when I want to train the model, I need some data, but I have to also validate that data later on. Validate that whatever model I've created, I have to validate that also. So I have, the data is divided into 3 parts, where some part, generally 60% is used to train the machine. And once it is trained, then you actually validate that model. Check whether this model is working, how strong is the model. If it is really good, it's able to make predictions, correct predictions, then you will choose, then you will use it. Otherwise, of course, you will try out other algorithms, or you may like to add some more features. In fact, a lot of variations you can try out. So this is how we train you in the data science program. So this particular problem would be of binary logistic regression, means when we are dealing with S curve, when we are dealing with yes, no types, you have diabetes or you don't have diabetes. It's binary logistic regression. So just was giving you some overview. What is an algorithm? What is a model? The best part is in Python, you can call a lot of functions. There are libraries available. You can use them. So a lot of work has already been done by someone else. You have to just learn the tricks, and that's what we train you in. Rishabh, I would like to hand it over to you. You can take it on from here if you want. You can show us how to, uh, you know, download Python if you want to go with the basics. I'll leave it to you the way you want. So are
Okay,
you?
yeah, sure.
Yeah.
I hope I am audible to everyone.
Yes,
And
you are audible. Yes.
good evening, everybody. So, guys, myself, Rishabh, and been working on machine learning data science from past near about 7.5 years almost. So, uh, I will today try to give you some insights on our base topic, which is Chat GPT. And even though before that, how Chat GPT came into the picture, and then bit on the Python, how do you have to download and all. So I'll show you those stuffs, and then post that I will get into Chat GPT and rest of the other factors. Okay, how to build a conversational AI platforms. So let me just quickly show you. Installing Python is super easy and simple. Just you need to go and write Anaconda, and once you just write Anaconda, it takes you to, you can see Anaconda, the most popular data science platform. So you can click over here. So every programming language needs an ID. Okay, integrated development environment. ID is required by every programming language. So we here also we need an ID, which will be basically mostly used with the help of Jupyter Notebook. So there are multiple ID, means where actually you write down your code, and that code get processed, Python code, and that get processed by its compiler and interpreter. And then finally, you get it executed and get your desired result. So the platform where you actually write code is ID, and that ID is connected to your Python compiler. So compiler is nothing but where your Python code is further compiled into a low-level machine language. Okay, and then after it gets processed by your processor, and finally you get the result, which is been your desired outcome. So in a way, this is in a very layman terms, and we basically try to show in detail in our training programs that how do we get into compiler, how do you execute and all. So you can come to Anaconda distribution, which is an open source. Open source means it's free of cost. Anybody can utilize this, and you can go ahead and download your Anaconda distribution. So this is very simple steps. Once you get it downloaded, you get to see Anaconda Navigator in your once you click on the search icon. Okay, you get to see Anaconda Navigator here. I can write it down, Anaconda Navigator. You can see Anaconda Navigator. I can open it out. It takes a bit time in your Windows system to open, whereas in Mac it is super fast and super simple. So once you have your Anaconda, once you initialize your Anaconda, you will get different type of IDs. There are many type of IDs. Each of these IDs, means integrated development environment, are based upon your usage. Okay, so some of them are based upon notebooks or scripting language. Means some of them are mostly based upon application development. So let me let it get started, and then I will show you. So it takes a bit time. Or else, means apart from this, you can also directly download Jupyter Notebook. Okay. If you download Anaconda, you get everything in place. You don't need to run here and there. Okay. Else you can download Jupyter. I think Anaconda has started. Yes. Yeah. So you can see, guys, this is what is your Anaconda Navigate. So from here, you just need to click on launch and your Jupyter Notebook will be ready. So you can see my Jupyter Notebook is already there in the system. And this is my Jupyter Notebook. And we come over here and we create a new notebook, and simply we can write Python codes and come to maybe downloads in any of the folder where you want to basically write down a notebook. So I can create a notebook. Okay. You can create a notebook by clicking on new and then which Python version you want to create with. I have different versions for my different environment. You might have a different versions. So you can come, you can see that I have clicked on new Python and a new notebook got created. Okay, so this is a new notebook. Inside the new notebook, you can simply write your Python code. Print, let's say hello world. Hello world. Okay, and you can hit on the enter. So this is how our this is how we write down Python codes, and you can continue from writing from here. So for those who don't know, they can follow these steps and they can pretty much write down the code. So it's a very simple way to install download. So once you download Anaconda, and just repeating once again, once you download Anaconda, click on Jupyter Notebook. There is two kind of Jupyter. One is Jupyter Lab, another is Jupyter Notebook. So you can click on the launch icon, and as you click over there, you can see a notebook icon on your taskbar, and you will be able to get it will automatically open in your Google Chrome. Once you open it, simply you can choose the folder where you want to write down your code or where do you want to save your notebooks, and then click on new, click on the Python 3. You will get to see this. Rest of them will not be visible to you. You can only see Python 3. So once you click over there, and then you can come to the new notebook which got created, and you can just print hello world. So this is how the entire notebook and code base are present. So now coming to conversational AI platforms. Okay, so I'll share my whiteboard first. So first, let us understand what is conversational AI platform. So it's basically like, from the word itself, we can understand that it's a chat bot. Now, typically, there has been a lot of evolution, which already you guys can see in terms of chatbot. You get to see a lot of evolution over here. And similarly, this is going to create a huge impact in the entire market. Now, one of the most important aspect of conversational AI platform is it can seamlessly talk like a human being and with a more accurate manner. But one thing that any of the AI platform cannot work is on the creation side. So far, it was not there. So natural language processing is one of the area. So AI is the complete universe, okay, and there are different type of subjects that are part of it. So one part of the subject is natural language processing, and natural language processing is of three different parts. Okay, so one is NLP. We call it as NLP, natural language processing, and then NLG and NLU. So NLP, NLG, NLU. You can also draw it in form of cycles. So first you process, then you understand, and then you generate. Okay. So like that also you can say. So NLP, then natural language understanding, and then natural language generation. These are the different layers. So natural language processing is basically going ahead and take any natural text, break down into some mathematical, you can say, representation, and then come to an understanding part, NLU, where we try to understand what is the relativity between the words in a given sentence. So when you say that I want to have pizza. So I want to have pizza, okay? Doesn't mean in nowhere we have written the word eat, okay? So, but the entire expression automatically tells us that you want to eat, or you want to take it on a dinner or lunch or a breakfast, whatever it is. You want to eat overall, but nowhere in the sentence I have used the word eat. Okay, I just use I want to have pizza. So language by default is very ambiguous. Means you say so many things sarcastically, right? But very hard. Sometimes human being, I express something very sarcastically, you may not understand it. Okay, so it is also, it's not a problem with machine. Like human being can also face some sort of difficulty while if anything is expressed in sarcastical manners. Machine do already have a problem because machine can only understand numbers. So that's why we take any given text, break down into mathematical representation, because computer don't understand other than any numbers, and that to 0, 1 at the very low level language. Okay, I'm not getting into the low level, but yeah, we take the data and we break into a mathematical representation which has some sort of semanticness. What is semanticness? These are the parts of language, any language formation, not only in English. You go to Tamil, okay, you go by Hindi, okay, any other language, Punjabi, any other language. So there will be a sort of semanticness, okay, apart from English. Means in English also we have. Now, what is that? What is semanticness? So when you say I want to have pizza, everybody can understand. But if I say I pizza want to have, will you understand? Or if I say I want pizza have to, doesn't make any sense, right? These sentences doesn't make any sense because you can't compute, you cannot understand this. And there where comes biggest challenge. As you cannot understand what you are trying to say or define, there was a biggest challenge. This is called semanticness. So we try to take any given natural text and we try to convert into a mathematical representation in a semantic manner so that it is preserved, the semanticness is preserved. And then we try to learn. So these sentences are of no use. So I'm writing down the correct sentence, that is, I want to have pizza. Now with this semanticness, we try to give some mathematical representation to each and every word, and we try to learn the semanticness between those mathematical representations. Okay, and then we try to understand, later on we try to understand that what does the pizza word mean? Okay, what does the want mean? When should it appear? Okay, if I want to generate something, I should know how to construct a sentence, right? If you go and ask 1-year kid, he will not able to answer anything because he or she doesn't know how to construct a sentence. So the first part is processing. What is everybody saying? Anybody saying mama, anybody saying dad? But the kid is not able to understand very efficiently until the same thing is being repeated to that kid, right? And then she can understand the pattern. That okay, when somebody is called as dad, he looks like this. Somebody is called as mom, he looks like this. Her voice is a bit different. So all those patterns starts getting embedded in our brain. And slowly we come to know that, okay, this is dad, this is mom, these are some other family members, and you get to introduce with new names. So a kid first try to learn those. And that is what is NLP, natural language processing. First, we try to understand the words. How can we pre-process the word? How can we make the word very simple? There are a lot of tenses in the word, right? And all the tenses will have a different word, but they mean the same thing. Okay. So for an example, choose, choosing. They are different set of words, but they mean the same thing, right? So these are part of your NLP. Okay. The next part is once the kid comes to know that, okay, this is mom, this is dad, then this is XYZ other family members, uncle, brother, sister, whatever it is. The next step comes is what are the different other words and expression that it comes to. So eventually the dad and mom, they also stop introducing themselves that I am dad and I am mom, because they know that their kids automatically understand who is dad, who is mom, right? So the next step is to frame a sentence and tell that you want to play with this or that. Okay, this is elephant, this is apple, this is ball. Lot of new things gets introduced accordingly. And these are not only introduced by words, later on we start introducing these words in a form of a sentence. And the kids starts learning the semanticness in the sentence. I want to have pizza. So at first the kid will not able to frame this sentence. So I will come to the generation part later on, but I will just make sure that how kid learn this, I want to have pizza. So there are different type of mathematical embeddings which are part of each and every word. So for an example, each and every word is given a word vector. Some numbers will be there. Okay, I'm just taking smaller numbers to make you understand. So, and then we try to understand the relativity between these two words. Means like if a want has to appear, something before that will be there. Whether it is I or they or he or she, some sort of reference will be there. It can be I, it can be they, it can be he, it can be she. Some sort of reference will be there, which will actually come before want. So what we do is, with the help of mathematics, specifically probability of getting want given that I is there. Okay, or probability of getting want given that they is there. Probability of getting want given that he is there. Probability of getting pizza before want means probability of getting want given that it is pizza. The probability will be very less, because we don't say pizza want. Pizza cannot want anything. So we don't say pizza want, right? So the probability will by default will be very, very less. You will not have those kind of sentences present. Okay, so by default you will be, the model learns that which are the words should be there and how they are related to each other. And this is only possible if you have a huge amount of data. With just one or two sentences, it cannot learn. Few TBs and TBs of data has to be pushed on large language models, we call it as, and then only it can learn the semanticness between the 2 words, 3 words, and eventually more. And that's where the sentence understanding part is targeted. The other way of learning is like in school days, if you remember, fill in the blanks. Now these all models of AI are basically inspired by the human journey of learning. So why those fill in the blanks were given in school days? Means many of you may not think that what is the significance of giving fill in the blanks. So I'll tell you the major significance of giving the fill in the blanks is, if I tell I want, let's say pizza is not there. I want, if I give you a story, if I give you a paragraph, and then I say that from the paragraph tell me I want dash to have. So the reason of giving fill in the blanks is to understand that the context, the meaningful context of the given content, whether it is a paragraph or whether it is paragraph or whether it is any other context. So that is what we try to derive. Okay, so fill in the blanks are not basically you won't in your graduations, in your master degree courses, you will not get fill in the blanks there in the question. The question pattern changes from your school days until the until your 10th, and then in class 12 the question pattern changes. In your engineering the question is different, in your master degree the question is different, in your PhD the question is different. Over there they don't ask fill in the blanks, because understanding the context, that maturity and that level of learning is been already completed in a particular age, and that's what very similar in the model as well. So the other way of learning is we try to skip the word and we try to predict. We try to skip one and we try to predict by its nearby words like I, pizza, and then again we try to obsolete pizza and then try to predict want and have. means using 1 ton we try to predict visa. Again, we want to close, we want to rule out have, and then we try to predict by its nearby words. So this way, this is also one of the mechanism of learning, the semanticness, meaning, and the context of the word, which word should be after which word. This part is the part of generation. So in generation, natural language generation, we try to frame the sentence, try to generate the response of the chatbot. So if I take a chatbot, it has 3 parts. One is whatever I am writing to the chatbot, I take that as an input, and then we pre-process that. That comes under pre-processing. We try to understand what is the meaning of the given context. Whatever I am telling to chatbot, what is that meaning? So that is being covered by the natural language understanding concepts. And finally, we want to generate a response on behalf of the context that has been given to us. So that we start with natural language generation, where we try to generate the context based upon our given sentence. So language model is very diversified model, lot of research going on. There are 1,000+ models there. Very hard to scale. Like if you see Chat GPT, it has not been trained in a year. It took 3-4 years to get it into that shape that you get to see it now. Lot of research has been done, and then it is now in a very humanoid manner, and it can ask any given question. I'm not sure how many of you have experienced it, but any question you want to ask, you can ask to Chat GPT. It can seamlessly answer. So I will today show you one of the implementation of some sort of similar model, okay, in a very quick short manner. I'll try to skip too much of technical jargons as of now. Probably after means if I put a heavy technical jargon, you will not able to understand the objective as of now. I'll try to give you the experience that how does a model looks like starting from end to beginning. And then we basically learn all of this in our course and journey. So one instance I'm just trying to show you, and this is a real-time industry implementation. Okay. So let me stop sharing from the whiteboard and let me jump into my notebook. Just give me a minute.
So in this program, we are trying to give you an overview of right from the ground zero to how an expert will be using the data science knowledge. So after you attend the session, typically it takes around 2 months, 3 hours of training, 2 hours of training actually every week, Friday, Saturday, and Sunday in the evening. In 2 to 3 months, you can become an expert. Means you can start developing your machine learning applications, etc. Yes, please go ahead. Yeah.
Yeah. So yes, now let me show you one of the implementation of one of the transformer models. So Chat GPT is basically based upon one breakthrough paper called as transformer. Most of you might have heard, and even if you have not heard, that's fine. So it's one of the very, you can say, robust language model that has been developed and designed so far. And transformer is one of the, you can say, it has different forms, and there are 1,000+ modification that has been made on over the transformer, and you have 1,000+ models available, which are developed on the top of transformer. Okay, so I will try to show you first that there is a paper called "Attention is All You Need." So, sorry. So this is the paper, and all other analysis are done on top of this paper. So I'll come to the architecture. So this is our architecture. It has a lot of functionality in this architecture, so I'm not going into too much of mathematical detail as of now. So this part is your encoder, and this part is your decoder part. Okay. The encoder part is known as BERT, which you get to also hear. Okay. There are two type of model. One is BERT based model, another is GPT based model. And the other part, this part is basically your GPT based part. Okay. Now, this is in a very simple term I explained. This part is BERT. Somebody only uses this much and then generate output. Somebody uses this much, the entire stack over here, and then they use the output. They generate the output. So that is your that is the other specific set of model. So one is GPT, another is BERT. Okay. So BERT based models are also language models, but they are used a bit differently, whereas transformers means your GPT are used bit differently. GPT is mostly used for text generation, whereas BERT can be used for many other aspects. One is, you can say, fill in the blanks, entity relationship, that is one attribute called name entity recognition or name entity relationship. So that is also there. There is another attribute which is your database table to natural language, which is very interesting concept. You have a database table, you don't need to write a lot of queries from your language, from your natural language converting into your SQL queries, or your natural language to database directly. You eventually don't need to query the you don't need to convert into an SQL query. So there are a lot of applications which are available, and this paper is one of the you can see one is the decoder part, another is the encoder part, another is the decoder part. Okay, so this is the decoder part, this is the encoder. Both can be splitted or can be used together. Okay, so now the the mathematical portions are covered over here, how attention is calculated and all. Attention means, let's say you have a word, I want to have pizza, right? I want to give attention to few set of words like pizza. Pizza is the word where I should give the attention. I want to have pizza at dinner. So when dinner comes, that also a part of your attention. So in a given sentence, not everything is important. Few parts of your sentence are important. Few words are important. So we need to give attention to those set of words. And that is known as attention. And these words also represent a category. So pizza represents a category food. Dinner represents the category time. So when a food and time both are provided, so it is very easy to understand that what type of food, is it a snacks or is it any sort of starter, okay, or any sort of dessert. And time defines which period, is it in dinner, is it in afternoon, is it in the morning hours. Everything can be captured under that category. So it's very and these categories are known as entities. Time is an entity, food is an entity. I want to buy let's say Hyundai new Verna. So what is Verna? Verna is a car. What is Hyundai? Hyundai is a manufacturing company. So Verna belongs to a car entity. Hyundai belongs to an entity called company. So entity is very important. And if we can recognize the entities, then we can eventually understand the meaning of the sentence, right? I want to buy. Buy is an action. Action can be buy, action can be sell. Okay, action can be anything. So buy is an action. Company is Hyundai, and your car is basically Verna. So if you can frame, you can understand the entities, it becomes very easy to express or easy to understand what is the meaning of the given sentence. There is some action associated with the company and its product, which is car. You can easily understand that, right? In whichever language you say, if you can understand, identify the category of the important tokens, it becomes very easy. Category with its sequence of categories. And that's what we come to know from the attention and the transformer models. We learn these things. Okay. Now coming back to the implementation, I won't take much time. So we are basically making use of some predefined model, which is T5 model. T5 model is now this is your theoretical aspect, whichever I explained. And there is a library called Hugging Face. And Hugging Face is basically a very well-known library. And all the transformer models, there are 1,000+ models so far now. All the transformer-based models, BERT-based models, all of these things are part of your Hugging Face. You can click on models and you get to see there are 1,000+ models, never ending. You can also see what type of job it can do: natural language processing, text classification, what type of text, what type of sentiment, then table question answering. This one just I said, you have a database. From the given database, you don't need to write queries, you write in a natural language. You will get an answer. So I'll show you. This is being designed by Google. Okay. So you can see that there is a table. This is your table. You can see. How many stars does the transformer repository have? Okay. 36542. And this is your table. Repository, stars, contributor, programming language. This is your database table. Sorry. This is your database table. From the table, you are putting a question which you are executing to get the answer without eventually writing any SQL query. Generally, we write SQL query, right? Select star from table name where repository is equal to transformer. We write a SQL query. In spite of writing an SQL query, we are writing the question directly and trying to generate results out of. Okay, so this is a very good solution. So like this, there are different other solutions as well. Anybody can use. Now Google has developed their model. You can develop your own model on top of Google's model. This concept is known as transfer learning. So you learn from somebody. Okay, I learned all of these things from different sources. And then I am teaching you guys. And then once you learn it from me, you can then further teach somebody else. Right? This concept is known as transfer learning. Okay. So eventually these AI models do also have a transfer learning mechanism. You learn from somebody and then you try to predict. So you can see over here, so we are using this T5 model. Okay. Our data is somehow looks like this. Just a minute. Just a minute. The notebook is very large, basically. It's too big notebook. Yeah. So you can see this is our data. We have the source and we have the target. So whenever somebody is writing, there is a potential risk value for the pair, then this should be the text. Means I have to train my data on this particular column. Okay. And I have to generate this. If somebody writes blue 3 has a potential risk value for the pair, so this should be the text. Means I have to learn this dynamic structure of the sentence and I have to predict this particular structure of the sentence, which is fixed. Prediction is fixed, but my input can be in a different natural language. So we used this particular transformer model and we used T5 transformer and we learned. So you can see very simple it is. we took the data which are useful. Okay. So we manually checked, there are somewhere around 500 records. We manually checked each and every record, and then we basically go ahead and whichever are marked as you can say, whichever are marked as means we manually go and check each and every record and see that whether the language is correct or not. So whichever is marked as we consider that, and finally we frame our final data set. Okay, and then we simply go ahead and call the T5 model over here. Okay, 100 epochs means 100 times iterations will be there, and you are basically learning that. And then you can see we have just passed all our data set into the T5 model, and finally you get to see the prediction here. It is just few simple lines. You don't need to get into the, you don't need to write whatever is mentioned in the architecture. Hugging Face and Hugging Face libraries will actually help you to get all of them provided. So you can see, once the learning is done, it takes time. It takes few hours, typically 3-4 hours. It is very expensive learning. Otherwise, I could have shown you right away on the today's notebook, but I cannot show because it takes 3-4 hours. And finally, once it completes, then you can go and predict. You see, I need to know the count of member born after 15 January 1996. Show me count of member born after Jan 15 1996. So we have given a representation, it has predicted in a proper representation, means in a fixed representation manner. How many female patients were attributed by every region in December 2020? Show me the count of female patients attributed in December 2020 by region. So it has learned, whatever I teach, it can learn. I have taught to get it converted into in a particular format of sentence from a random sequence of sentence. I have transformed to form a particular sequence of sentence, and finally these are the set of predictions, which is very accurate. You can see most of them are in a proper form. Clear? So this is how the transformer model works, and it is very important to understand the fundamental of it, and that you can only come to know, like there are a lot of things in between which are present and which you need to learn. Many things are there. Post that, you can kind of build this kind of models. So that's one of the implementation, and it's a real-time implementation. I'm showing you one of the practical implementation. So sorry, Hugging Face is basically the library you guys can explore, and yeah, it's one of the most popular libraries so far, Hugging Face, and that gives you a lot of advantage. You can see language model varies from language to language. You can't expect English language model to work in any other language. It cannot work. So it varies from language to language. So language model you need to train first in your own custom language, and then finally you can jump into other language in your custom language. So far, whatever I explained, anybody any questions?
And we understand that most of you are totally new to the data science. So instead of keeping this program only at the basic level, we just wanted to know, wanted to show you that how an expert, like after 3-4 months of training, what would be your capabilities. And trust me that data science is not difficult. It just requires practice. So you have to undergo the training. We give you all the training material and also all the recordings of the training once you join our course. And once you get all the recordings of the training, you can watch them many times. You can practice, you can learn yourself. And once you develop write the code yourself, develop the models yourself, and you will become a master. So many people in the last 2-3 years have really started their successful data scientist career after completing our course syllabus. You can join our course as many times if you want. Like if you want to join the next batch, feel free to join. There's no extra cost, but of course you have to pay for the first enrollment, and after that you can join the sessions any number of times. So this is how a typical sessions with us works. And if you are interested, please click below the link, which is on the Naveen has just sent you the link. So you can just register your interest, and we'll be getting back to you. Yeah, Rishabh, please continue.
Yeah. So guys, as you already heard, that practice is required. In our training, we try to give a lot of industry-driven assignments, projects that are the real-time problem statements. Nowhere else in any other program, in any other machine learning or data science program, you won't get any real-time industry data. But here we try to, even the today's content that I showed a glimpse of code, that was also one of the industrial use case. So you need to learn how you collect the data from different sources, how you make the data ready, and then comes the ML part or the DL part, whatever it is, which is very late in any ML DL project. So if you take 100 days to complete a project, typically you can take 70 days in making your data ready for your algorithms to take. So now you can imagine that more than the ML and the DL side, we take a lot of time in pre-processing, making the data ready for our ML/DL projects. So that's what we heavily focus in our first phase of data science, that you get ready with an understanding how to pre-process your information and how to make your data ready for your ML/DL. So that's a heavy lifting part, 70% of any data science project, because algorithms are now being used by libraries. You don't need to write any mathematical logic or fundamental. You just need to use it. That's it. Okay, but the major part comes in before you go ahead to use, make your data ready. Most of the open source projects, or if you see the projects in YouTube or Kaggle, the data is already pre-processed and ready, right? So you basically miss that 70% of your learning, how to pre-process and manage the data to get it ready. So that's a huge difference between the reality and the practice of the practical part of any data science project or courses. so that you get an exposure over here, basically.
Yes, so we would encourage you, and we would be happy if you join our courses. And as I said, the course is totally practical. We start from ground zero. We start with the basics of Python, and also Rishabh, you have something more to say, more to add?
Yeah, I'm done. Almost here. Anybody have any question on the technical side, you can ask me.
So I'll give you the dates, and if you are interested. Once again, I'll show you the topics which we cover in our data science programs. So we have 3 levels: basic, intermediate, and advanced. Basically, we have got these topics which we cover, which also includes the ML algorithms. And also intermediate, we go to NLP, NLU as well. And in advanced, we cover the neural networks. So we also help you in getting the recruitments, and also we prepare you for the interview sessions and interview questions also. Training is on weekends, Friday, Saturday, Sunday, starting on May 5th. And the training times, if you join, these are the training times. And Friday, Saturday, Sunday, the 3 days of 2 hours. In next 3 months, you can become a data scientist. So some of the upcoming free workshops, we do conduct a lot of free workshops: PMP workshops, CPHQ, Yellow Belt training. One more data science free workshop is coming up. There we'll be talking about another topic. Today we focused on the NLP part, ChatGPT part. There we'll be focusing on another topic. And we also have Power BI training, and most welcome to attend all these trainings. They're totally free. So stay in touch with us. You would be, if you want more information from us, always a good option to click on the, just go to LinkedIn and follow our Anexas page, Anexas LinkedIn page, or Facebook page, or Instagram page. We put all our announcements there. You can also stay in touch with me on LinkedIn. You can just follow me, and you'll get a lot of updates from me. Almost every day I write something about management, strategy, quality, or data analytics. So thanks a lot for joining our training program. And once again, if you are interested, please click on this link and get your registrations. And thanks for joining today.